Lesson 6, Modules, Organization, and Optimization. Module scripts and examples of how to use them. Module scripts are reusable scripts that store functions, data, or both. They allow you to centralize logic so you don't have to rewrite code for every script. This helps with efficiency, scalability, and debugging. Here is a module script. Module scripts, as you can see, are purple. These module scripts do not run on their own. You have to use them within other scripts, whether they be server-side or local. You can use a module script for both server and local scripts. As you can see, this module script we're having two functions. This function add and this function multiply. We're passing in A and B and giving the sum of A and B. And here we're giving the multiplication of A and B. So as you can see, this is how you require the module script. You do whatever variable name you want. I could have this variable name be whatever I want. And then you do require. And then you get the location of the module script, which right here we have it in replicated storage. And then to use the function, all you have to do is how you would use it in a regular script. You just do the function name, and then the module name, and then the function, and then pass in the two variables. So since I'm doing the module, you can see right here the module dot add, and pass in the two numbers, and then I'm printing the result, which is 15. So if I run this, it'll print 15. As you can see right here, prints 15. Now, one thing to know is that it doesn't matter what I name this variable. I can name this variable high, and it still will work. See? And another thing is inside of this module, you can name this whatever. You can just name this module if you want, and it'll still work. It doesn't matter what you name it. It's just good to name it based off of what it is. So, things to think about. You create a function that you can use from other scripts by doing function, the module name, right here. This is what you name the module. So if this was module, then I would do module dot times, enter, right? That's why these ones are red, because it has to be module. But as long as it's math utils, then that'll work. So you do function, the name, and then you can either do colon times, or you could do dot times. The difference between that we'll get into at another time, so they don't really matter right now. You could do either one, whichever one you want. Usually I do the colon for actual functions, and I'll do dots for more like settings or values or configurations. So if I go back to the server script, you'll see right here, if I do math utils colon, you see it autocorrects already because it already knows that it's there. Times, already sees that it's there. Now if I were to do local function, right, this won't work because it cannot be local. Local means it's only to this script. It has to be function, modules, whatever. It won't work because it has to be function, the name, and then the times. It cannot be local. So if I were to try right now, you see it doesn't see any times. You can keep the local functions within the utilities if you want. Like I could do just a local function, and then I can use that local function inside another function that I can pass for other scripts, like this, and this will work. If I do use, you see it'll run that local function. But to be able to use it from external scripts, it has to be function, the module table name, colon or dot, function name, parentheses, and then end, and then your code inside. Next, we have a module for moving an NPC. In this module, we have a function called wander. We're passing in the NPC and the points of where we want the NPC to walk to. So right here, as we're doing before, you have to require the module first. It's inside replicated storage.pc, and then I'm going to get the NPC inside the workspace, which is right here. And then I'm going to make the patrol points, and then I'm going to run the function, pass in the two parameters, the NPC and the patrol points. And then when I run this, you'll see that every 5 seconds, he'll move to one of the points. See, he moves to that one. Then he moves to that one. And then he moves to that one. Just like that. Next, we have organizing scripts, assets, and other game files. So if you look in here in this replicated storage, this is how I usually organize all of my game stuff for each individual game. This file would usually be the entire game with all its assets, all its scripts, all its GUIs, client stuff, configurations, everything. I put the game file, and then for each individual property inside the Explorer, they do workspace, lighting, replicated first, replicated storage, server script, server storage, starter GUI, starter pack, starter player, starter care scripts, and starter player scripts. And for everything, I'll add the scripts for events. I'll add the modules and the replicated storage. I'll add all the GUIs for the players, all the backpack items. I'll add all the scripts and skills in here, listeners and special lighting effects, or the map inside the workspace. And then I'll have one singular script inside server script service that basically looks into this file and moves everything into the respective place. This way, so whenever you have another place, when you have multiple places in a game, say you have multiple worlds, you don't want to have to go through every single tab and copy everything. Instead, all you have to do is just copy this file and then paste it into the other place. So that's for neat organization for all your assets, scripts, and everything. Next is organizing code and writing shorter methods. As you can see right here, these first 3 lines, we're changing the parts colors 3 times, right? Part 1, changing the color. Part 2, changing the color. Part 3, changing the color. Instead, what we can do is just make a table for all the colors, and then for each part that we find, we change the color based off of the index. So the first index is going to be the first part, and so it'll do colors, and then it'll set the color to this first one, red. And then the second time it'll be the second index, so it'll get the second color in the table, which is green, and change that part to green. And then the third time it'll change it to blue. So this is for simplification of code, better than constantly writing useless code that just is repeat. Next, we have another utility module that helps to move repetitive logic into utility modules to reuse it anywhere. So in this utility module, we have a function that changes the part color of any part. So all you have to do is just pass in the part and then set the color, and it automatically will change the part's color for us. That way we don't have to go through every single script and write new code for changing the color. All we have to do is just write 2 lines that pass the part and the color. Next, place scripts where they belong to ensure clarity and optimize performance. For example, server scripts usually go into server script service or server script storage. Server script storage, as again, is no code runs in here. It's only for server scripts, no code runs. But in server script service, code does run, and it's only for server scripts. You would put stuff such as NPC AI, data storage, game events, stuff like that. Workspace is for all the parts needing direct interaction with the player and the server. Starter player scripts, you want to put all your player controls or GUI logic. And then in starter GUI, you want to put all the screen-based elements like the HUDs and stuff. Character scripts you want for like animations or sometimes like certain items like the armors. Next we want is using open sourced modules. As you can see here, we have this module, Camera Shaker. This is an open source module made by someone, CrazyMan32. And basically what it does is it's a preset for making the camera shake. Such as when you have those cool effects where the camera shakes for explosions, or when the camera shakes for like when it rumbles or whatever. This is what you use, this camera shaker. And inside the camera shaker is more modules that the camera shaker requires. So you can require a module within a module. So this module requires a module within a module, and they have certain types of shakes. So these are preset shakes, like you can do a bump shake, explosion shake, earthquake shake, vibration shake, all these different types of shakes, and you can even make your own. So right here in a local script, we're requiring the camera shaker, we're getting the player's camera, and then we're making a new camera shake, and then we're going to wait 5 seconds after the character spawns in, and then we're going to just do a little bump shake. So if I play this, you'll see after 5 seconds that my camera will shake a little bit. And there you go, that's a little tiny shake. And now let's try a different one. We can try, let's see, what presets are there? We could do explosion. Let's do explosion. So now if I play this and we try explosion, it might be like a bigger camera shake. So wait 5 seconds. And boom, you can see the camera shakes a lot more. Key takeaways are modules centralize reusable code for efficiency and scalability. Use folders like assets, scripts, and modules for clarity. Automate organization with setup scripts, such as with the game file. And then for code optimization, refactor repetitive logic and clean up event connections. And then for script placements, place scripts appropriately for better performance. And then for open source modules, use these trusted open source modules for advanced features, but customize them as needed. And that will be the end of this lesson. Now it's time for the activity.